All right, picking up right where we left off, we're going to look at operations with complex numbers in the polar plane now. So we've talked about complex numbers. You guys did in Algebra 2, college algebra. You can add them, subtract them, multiply them, and divide them. So what we looked at is complex numbers in polar form. So the first thing is they look like this. So we have any complex number. Here's the real axis, here's the imaginary axis. We just plot this thing in rectangular form. So -3 minus 6i would be somewhere down here. Okay, we want to represent that in polar form. Polar form is anything with an r and a theta. So we need the appropriate radius, we need the appropriate theta to get there. We said it was this form right here. Okay, so z is your complex number. R is your radius. A lot of you guys kind of forgot about that I on the quiz. Okay, so it is still a complex number here. So that's how we write them. We get these two formulas that we basically just plug things in without a ton of meaning with. How you multiply complex numbers, how you divide them. We did the proof for this guy. We basically just took Z1 and Z2, double distributed, used our yellow sheet, came up with this. You do a similar thing for the division one. Okay, nice thing with this, tons of overlap with what we've already looked at. So it gives you another chance to practice that and refresh it after the break here. So this looks at this guy named DeMourve. Probably not saying that right at all. Thankfully, he did all this work for us, so we don't have to prove these things. He's got a huge effect on the world of math. I encourage you to look him up, see what else he's done. Okay? So what he let us do is get complex roots. I made up a quadratic here. Okay, 2x minus 5 quantity squared plus 5. If I graph it, okay, I made it that way on purpose so it never hits the x-axis. This guy's got complex roots. Okay, so it doesn't have an answer of x equals 2 and x equals -5. It's got some answers with i's. So if we double distributed all this stuff, put it in standard form, did quadratic formula, we'd find it never hits the x-axis because its solutions would be something like, I have no idea if this is right, I'm just making it up, 3 plus or minus I squared to 7 over 4, okay, let's say. So we know those are complex solutions. Okay, we want to do the same thing with polar stuff, and that's what DeMourve lets us do. If I give you this, which is clearly just a complex number in polar form, and I say raise it to the 4th power, okay, you could say, well, if I could somehow turn that into a rectangular number, let's make up a new rectangular one here, -6 plus 7i. So you could take that and you could raise it to the 4th. But who wants to double distribute stuff 4 times? So you got to do these two, and then you branch that product out and you do the other one, and on and on. Okay, it's a lot of legwork there. So he came up with this theorem that lets us do this. Okay, so you could sit there with this and take that whole blob and put it there, 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 and there. Double distribute these two, then move on, and that's a lot of work. Okay, you're going to end up with i's to the force, you know, sines to the force. A lot of stuff happening there. Okay, so he's got this formula for us. All right. What he says is if we take any complex number in polar form, written with this guy right here, okay, if we're raising it to a certain power, so that's the z to the n piece right here, this is it. Okay, it's rather quite simple. All right. Some of these proofs are a little difficult. I'm not going to take you through them. You can look in the book. This is one case. I'll just let you accept stuff coming out of the Math Magic hat. So all we got to do to double distribute these things numerous times is follow this formula. So we take our complex number, radius goes to the n, as you would imagine, and the n just gets multiplied by the theta, there and there, and that's it. Now this only works for powers greater than or equal to 1. So no negative exponent stuff here, but that gets even uglier. Okay, so first power, second power, third power, so on. If the n's a 1, if you're raising a complex number to the first power, these go away, and that's exactly what we've been working with. Okay, so first thing is we got to practice how we would do this. There's the same one you guys have seen, so we're going to use this, not double distributing it, but we're going to use the formula here. Okay, so copy the formula for us down here. We're just going to pretend this is our z. So we want to do z to the 4th. All we have to do is plug some stuff in. So it's going to be 3 to the 4th. The theta right now is a 30. And we're just going to multiply. And simplify this as much as we can. Now, you've seen things in that form before, so that's obviously in polar. We look at the directions. Write this polar number to the 4th power in the standard form a plus bi. So now here they kind of switched it up again. Before they used to use y's and x's, now they're back to using a's and b's. Anytime we see an I, it's just a complex number. So you guys have done this problem right here. All you have to do is go evaluate. So grab your unit circle, hopefully you can draw triangles, and literally just plug in what these values are here. That's how you transform them from polar to rectangular. So 120 is over here, that means that's a 60, so there's your 30. So cosine of this guy is -1/2. Sine of this guy and we just distribute. I'm going to squeeze the I in there here. And that's all they want. You can leave your answers just like that. Okay, so all we did is things we've done before, except we're now using this formula, and then we plug in values for sines and cosines of certain angles. Okay, so that's how we expand complex numbers in polar form and then change them back to rectangular. So one step on what we've already looked at. All right, what if they want you to take this guy? So it's in rectangular and raise this one to the 4th. Again, we don't want to do all this in the double distributing. That's going to take us forever. Okay, we have a formula here, but this formula only lets us do things that are in polar form. So we may have to take this guy in rectangular first and change this over to polar. So write this in standard a plus b form. Okay, first thing I'm going to do, figure out where this is, what my radius is, and my theta. So I'm going to figure out where this guy is. Okay, it's going to be in quadrant 2. Seems a lot of things are. Now this is a 1. Okay, we don't need the I in it now. Okay, to find the radius, we know those values. So that's just going to be a 2. Okay. Only other thing now I need is a theta. Well, if I know this is a 1, square root of 3, and a 2, that means this guy's 30. So what I care about is 150. Okay, starting in part 2, we'll try and put this stuff together.